Hi, in today's tutorial we will explore how to use a pre-trained image captioning model from Hugging Face in order to analyze images and automatically generate descriptive captions. So we will use PyTorch and other vision transformers for image coding. So let's start. Let's start with the installation part. As you can see here, I will leave a link for those two images. This is the first image and this is the second image, and here this is the installation instructions, and we will do of course some Python coding to run all the process. So let's start with the installation. Let's open Anaconda. And as you can see, here is all the instructions for the process. The download of the model, I believe we will try to download it later, since maybe the code will download it automatically. So let's leave this part and we will start with the Conda environment. So let's create Conda create minus name, and let's call it image cap for captioning. This is the full word. We can use the full word like image captioning. Let's copy the full command. So here it is, and let's run it. Let's click here, proceed. And now we have to activate this new Conda environment. We can copy and paste this command. And here, as you can see, this is our current Conda environment. Next, we have to install the PyTorch, and we will, first of all, we have to define which type of CUDA version we have in our environment. So let's type here nvcc --version. As you can see, mine is 12.1. Maybe you have another version like 11.x. Basically what we have to install is PyTorch 2.3.1. So let's open our browser and let's go to the PyTorch website, and as you can see, the last version is 2.4 and we need 2.3.1. so let's go to the previous versions. Where is the previous version? Here, install previous versions, and we need 2.3.1, and this is 2.3.1. and as you can see, we have an install command for CUDA 11.8, we have for CUDA 12.1. so let's copy this command. This is for 12.1. Let's run it. Great, so we finished install PyTorch. Let's go back to the instruction file. I can see that this command is for CUDA 11.8. Let's also leave the one for CUDA 12.1. So let's leave a comment here. This is CUDA 12.1 and this is for CUDA 11.8. And once again, how to find your CUDA version, type this command, nvcc --version. Next, we have to install two more Python libraries. This is the first one, transformers. Let's run it. So we have an error here. Let's see once again, pip show mkl. So it's not installed. So let's install it as well. Pip install mkl equals 0.1.0. And once again, let's run the transformers, the installation of transformers. And as you can see, now we have no error. So let's copy this command as well, so it will be part of the installation. Great. And the last one is OpenCV. Great. So we finished everything and our environment is ready for the Python coding. So next step would be creating our new and fresh Python file. But before that, we have to choose the relevant interpreter. So let's choose our conda environment. We name it image captioning, and now we can start our Python coding. So let's create a fresh one. We will name it image caption.py. First of all, we will start with importing the relevant libraries and modules that will help us with the image captioning. As you can see, we will use vision transformers in order to achieve this task. We will also import the PyTorch and Pil for dealing with images, and OpenCV as well. Next, we will load the pre-trained model from the image captioning, which combines a vision encoder with a text decoder. So this is the name of the model. This is the link for the Hugging Face. Let's copy and paste the full link. It will help us with the copy paste, since we will use it in more Python commands. So this is the link. Of course, I will leave a link for this code in the video description. Then we create a feature extractor that prepares the images for the model. We will send the same pre-trained models as an argument for this function as well. We also load a tokenizer, which is essential for converting the model outputs into a readable text. Now let's check if we can use a GPU for faster computing. Otherwise, we will use a CPU instead. So this device variable will contain the values of CUDA or CPU. Here we set the parameters for generating captions, the maximum length of captions and the number of beams for the beam search. Now we will create a function that will help us to run through all this process. So we will define a function that will take a list of image paths and predict captions for each of those images. We loop through the provided image path to open and prepare each image for the processing. So now we are grabbing the first image path, and we will open and load the image into this variable, and then we will ensure that the image is in RGB format, as the model requires this. So if it's a non-RGB, we will convert it to an RGB format. And then we will append this image into our list of images. Great. Now it's better. Now we will extract features from the images using the feature extractor, preparing them for the model. So everything will be stored in these pixel values. And let's print the result only for our debugging. It should be pixel values. Great. Now let's move to the next step. And in this step, we will move the pixel values to the same device as the model for the computation. Now we are using the model. We generate the output IDs which correspond to the predicted words for the images. So all this will be stored in the output IDs. Once again, let's print the result. Finally, we decode the output IDs into human-readable text captions and stripping any special tokens. Okay, and once again, let's print those final results. And this function, we will return those spreads as return values so we can use it later. Now we define the path for the images that we want to caption. We will use two images, one of a dog and the second one of people in a picnic. And this results value will contain the return value from our function. We are sending the path, the image's path. Another error is fixing the name of the variable. It should be tokenizer. And also I forgot to match between the device and our model. Model should figure out if we are using GPU or CPU. And also if we change the tokenizer, we have to change it here as well. Great, so let's run it. And now, as you can see, we have two strings. One is a brown white dog sitting on a rug. This is the first image. Great results. And the second one is those people sitting in a picnic. So it's working well. Let's do another step, which is displaying those predicted text, those captioning along with the image, along with those two images. So let's run a for loop through those images path. Let's load the images using OpenCV. and we will use the putText function in order to display the text along with the image. So this is choosing the position of the text, the font, how thick should be the font, and also the color of the font. That choose the red color, and we will display the image and wait for a keystroke. So let's run and see the results. So this is the first image. As you can see, a brown and white dog sitting on a rug. And let's see the second one, people sitting around a picnic table. Thank you very much. I hope you enjoyed this tutorial. You are welcome to subscribe. Bye bye.